Hello friends, welcome in your physics class. For complete course, press subscribe button and bell icon and watch our videos regularly. Let's see the change in internal energy of the system. It can be carried out in two ways. Let's go in detail. Consider a gas in a rigid cylinder. This cylinder is provided with movable, massless and frictionless piston at one end. The gas inside the cylinder is our system and rest is the surrounding. For more detail about the system and surrounding, I will recommend our previous video. The link of this video is given in the description. Check it out after this video. The first way that we are learning is by heating the gas. In this process, we heat the gas by heating cylinder externally. Therefore, temperature of gas starts increasing. Friends, we have learned in KTJ that when the gas is heated, RMS speed of gas molecule increases and therefore its molecular energy also increases. In thermodynamics, this molecular energy is called internal energy of the system. So by heating gas, internal energy of the system increases. The gas expands on heating and pushes piston outwards. Friends, all walls of the cylinders are rigid except this piston, which is free to move. And as it is free to move, so on expansion of gas, it moves outward. Piston moves due to force exerted by the gas. Thus, gas does some work on the piston. On the other hand, if the hot gas is allowed to cool in the surrounding of lower temperature, then gas gets compressed during the cooling and piston moves inwards. During this process, heat is transferred from system to surrounding. If the surrounding is huge like atmosphere, then change in its temperature will be extremely minute and unnoticeable. Now the second way of changing internal energy is by doing work on the gas. For doing work on the system, we need external agent. It could be you. If you push the piston inwards quickly, gas gets compressed. Here, piston does some work on the gas, that is system, in moving some distance. Here, piston does some work on the gas in moving some distance. मतलब surrounding system पे work कर रहा है. The gas gains energy and its temperature therefore increases. Now, if you allow the gas to remain as it is, the gas pushes piston out क्योंकि gas expand हो रही है. Now, gas exerts force on the piston to move it outward and does work on the piston. During expansion, gas loses its heat energy and cools down. Please pay attention. Here, gas spends its internal energy to do external work on piston. Hence, its internal energy changes. Conclusions of these experiments lead to us a very important principle of thermodynamics, the first law of thermodynamics. The first law of thermodynamics gives the mathematical relation between heat and work. The law states that if an amount of heat Q is absorbed by the system, a part of it may increase its internal energy dU, while the remaining part may be used up as an external work done by the system. To understand the law, come back to our system. As piston is moved out, the gas gets expanded. During the expansion of gas, molecules of the gas strikes the piston. Therefore, loses their momentum to it. As a result, gas exerts pressure on the piston. The force due to this pressure acting on the piston is given by pressure exerted by gas times cross-sectional area of the piston. Direction of this force and the displacement of piston are same. Hence, positive work is done by the gas on the piston. Let us see the mathematics involved in this process. Let Vi be the initial volume of the gas, and after expansion, its final volume be V up. During this process, piston undergoes some displacement. Let dx be infinitely small displacement. Displacement is taken infinitesimal to consider instantaneous change in volume. Hence, to calculate work, we use method of integration. Thus, work done by expansion of gas on piston is W equals integration between the limit Vi to Vf of F into dx. As force equals pressure times area of cross-sectional of piston, so above equation becomes as A times dx is nothing but change in volume of the gas, that is dV. So equation becomes as shown on screen. As P is constant, taking it out of the integration, on solving this equation we get W equals pressure times Vf minus Vi. This is equation 1. Now this result reveals many other facts about this process. If the gas expands by heating, then Vf is greater than Vi, which implies Vf minus Vi is greater than 0. Since the change is positive, therefore work done is positive. Thus, according to first law of thermodynamics, Q equals du plus W. If the gas is compressed, then final volume is less than initial volume. This implies that change in volume is negative. Therefore, work done is also negative. Thus, the law of thermodynamics can be written as Q equals du minus W. If volume of the gas remains constant, then final volume equals initial volume. This implies that change in volume equals 0. Therefore, work done equals P times change in volume is also 0. Thus, from the first law we get. दोस्तों उम्मीद करते हैं आज का विषय आपको समझ में आ गया। आपके विचार आप कमेंट बॉक्स में डाल सकते हैं। दोस्तों अगर इस चैनल पर आप पूरा कोर्स फ्री में पाना चाहते हैं तो बस सब्सक्राइब का बटन दबाकर नोटिफिकेशन का बेल आइकॉन जरूर दबाएं, और यदि आपको वीडियो दिल से पसंद आया तो सोशल मीडिया पे अपने दोस्तों के साथ इस वीडियो को ज़्यादा से ज़्यादा शेयर करना ना भूलें। चलिए दोस्तों फिर मिलेंगे नए वीडियो में। बाय बाय।